Okay, we're back. Alright, now it's proxy in synchronization time. So let's continue on from the script. Now before we have the client sending information to the server, and then the server process that information. It check the velocity, and then it move the character, and then it validate the new position, and then it correct the owner if there is anything wrong, and after that it sends the new position and rotation to the proxy. Well, in order to synchronize with the proxy, we can simply just move the position to whatever the server sends, and here's the simplest way here. And here I'm just I disable my other code, and then just do that. Just move the position of the proxy to the server's position, and then I will show you what happened. Okay, now I'm gonna run this server, and I need to run another client as well in order to see the proxy. So here's another client, and then here is another client. So I'm just gonna run that and then log into the server. There's a bug here with the camera, so I have to click on it to refresh whatever is wrong with the camera. I just need to refresh the script here so that it works okay. Nothing, no big deal here. So I'm gonna run the client and log in. Okay, now let's log into another client here. Alright, so this client is synchronized with the server, and it's also sending the server is sending the position information to this client here in the editor. And then this the proxy here, we have proxy object here, will just simply move to the position that the server sends. So here we go. So every 100 milliseconds, that's the rate that the server sends the data. So it will just jump to the new position that the server sent, and yeah, it kind of works. It does give the position. You can see the new position in this client here. It's quite precise, but the problem is that it just jumps around. It looks very jumpy, as you can see, and we don't want that. So in the common practice in the MMORPG design, they do the interpolation. Okay, what does that mean? So here's what happened. What happened in that example? We have the server sending the data every 100 milliseconds, and we simply just put the character at that position. I mean, that's why it looked very jumpy. So we just move directly every 100 milliseconds. So what we want is we just want to smooth out the position. That means every update we want to just guess or interpolate the position in between this 100 milliseconds here, because we are running at a much faster rate. Let's say we are running at 50 frames per second. That means it's 20 milliseconds per frame. So there will be 5 frames or 4 frames here. So 5 starting from this point. And so there are 4 more frames that we want to interpolate in this position. So, and if we can do that, the position will look a lot smoother than what we see just now. So yeah, that's the job of the proxy synchronization. We just want to smooth out the position that the server sent to the client, so that we get better experience for the player. So how do we do this interpolation? Well, it's quite easy. We have first we need 2 data. we need one data here and one data here, so we know the position at this time and another position at this time. And then we can just do an interpolation. We use in the script, like in the one that that uLink use, we use they just put lerp, Victor3 lerp. It doesn't really matter. You can use any interpolation method you want. So for example, we have this frame over here, which is at 820 milliseconds. We simply take the difference between these two locations. Let's say it is 1 meter. We move 1 meter in this 100 milliseconds, and then at 820 milliseconds, that means we move 20% of that 1 meter from this location toward this location. That's it. It's quite easy, really, because we don't need to do anything really complicated, because the time frame is really short. It's only 100 milliseconds. So as long as we can calculate something that is quite reasonable for the position, it should be fine. So yeah, we just need to take the difference, and then we just look at how different it is from the frame that we are trying to render, compared to the older frame. We call this the left hand side, and this is the right hand side. And so we just take the difference there, and let's just add it to this position. So 20% of the whole distance, just add it to this position and move on. And we do that the same way for the next frame. It's 40% of this thing, and then 60, and then 80, and then here it's 100% of this position. So we can just take this position straight away. It's fine. Okay, that's the idea for interpolation. But the complication come with when we have delay, when we have latency in the network. So that's when we need the interpolation back time here. I will explain it shortly. So let's say we want to render this frame here at 800 milliseconds. So how soon can we render this frame at 800 milliseconds? Okay, let's say the game starts, and then the server starts sending the data here, the data of 800 milliseconds. So the game starts at 800 milliseconds, and we want to render this frame, but we cannot because there is no data. So we have to wait for this data to arrive, and it will arrive at 60 milliseconds later. So at 860 milliseconds here, we get this data, but we still cannot render it yet because we want to wait for another data in order to do the interpolation in between. Yeah, we can move it immediately here, but then the next frame we cannot do anything because we don't know the data after that to interpolate. So we want to wait until 900 milliseconds here arrive. So so we have to wait until 960. So at 860 milliseconds, we have received this data. Now we have enough information to do interpolation. So at this point, we can render this frame at 800 milliseconds. So we can just take this 800 millisecond here, position at 800 milliseconds, and then just move the character to that position. And then at the next frame, which is 820 milliseconds, we have the information to interpolate. So at this frame, we just interpolate the from 800 to 900 milliseconds. So we take the 20% of the distance that change from 800 to 900 and put it here, and then we can interpolate and so on. But this is just for ideal condition. I mean, at 960, we are assuming that this data arrive before the update happened, before the update function run, and we also assume that the data does not have any delay. we are assuming that it is exactly 100 milliseconds after 800 after the 800 millisecond mark here, and then exactly 100 milliseconds the new data is sent, and then exactly 60 millisecond delay the data arrive, and then we update after that. So a lot of assumption here, and so this is only for ideal condition. I don't think it's possible to just render this data at 960 milliseconds here. So we need some kind of buffer in order to handle fluctuation in network time. So that's why I put interpolation back time here at 200 milliseconds. In normal cases, 200 milliseconds is a good number. It can handle a decent network. But we need to change this depend on the condition of the network. If it has more delay, then we have to change the interpolation back time to, we have to pull it back maybe to 300 milliseconds, something like that. So yeah, in ideal condition, in order to render the 800 millisecond time, we have to wait until 960 milliseconds. That means the interpolation back time at the minimum is 160 milliseconds. But we need some buffer, so we put 200 milliseconds just in case. Well, that's the that's the idea for the proxy. Let's check out the code. So here I'll just delete that simple way of implementing the synchronization, and I will just uncomment my stuff first. Okay. So what's the first thing we do when we get the data? As I said, we need to be able to store these data. So that's why I have an array. So whenever the proxy receives the new information, it just prepare the array and insert the new data into the position at 0. The proxy states of 0, I put the state there. So I want the newest state to be at the front of the array all the time. So in order to do that, I have to move the older one to the right. Yeah. So and for the oldest one at 20 here, I have the array at I have 20 size. No, I mean, yeah, 20 object size in that array. So the one that is oldest, the one at index 19 in this case, will be deleted every time, and then make space for the new one. Yeah. So after that, we store that, and then we just leave it there, and this is where the proxy do the interpolation. So we do it every update because we want it to look as smooth as the owner's performance. So yeah, the way we do it, first we have to calculate the interpolation time, and to do that we just check the current time and then subtract with the interpolation back time. See, for example, we have our current time is 960, and then our interpolation back time is 160 milliseconds. That means we are trying to render the frame at 800 milliseconds. And if we want to use interpolation back time of 200 milliseconds, that means we have to wait until 1000 here. At 1000, it will try to render the frame at 800 milliseconds. Alright, so yeah, we calculate the interpolation back time, and then next we check, we try to find inside our array. Let's say we are at a position at 1000 here, and then so that means our interpolation back time is at 800. And then we have to look into the array. Let's say we have the array, but at 1000 milliseconds here we don't have this data yet, we only have these two. So we look at the array, we have 800 and 900. So we check the one that is we try to find where we are in between two data. So we find that we are at 800, so the next one is 900. But let's say we are at the frame of 1020, that means we are at 820 milliseconds here we try to render. So our left hand side is 800 and our right hand side is 900. So we choose these two data. Let's say if in an array we have many more data, we have to check to find where is the left hand side and where is the right hand side in order to interpolate. So this is what this bit do. How we do interpolation here, we just look through the array of the data and we try to find the right hand side and the left hand side here. The right hand side and the left hand side, we try to find that, and then we can use those data to do the interpolation. I don't need to go explain in detail all this code. You can check them out by yourself. Here at the end we use a loop to interpolate between the left hand side and the right hand side. And yeah, this is extrapolation, and we need to do extrapolation just in case you know, sometimes the network can be delayed, or maybe one data is lost, one packet of the data is lost. In that case we don't have enough data to do interpolation, so we need to do some guessing, and that's what extrapolation do. We simply try to guess based on the previous movement. For example, here we are moving at a direction at 1 meter per second, or 1 meter per 100 millisecond here. That's 10 meter per second. That's the speed. So we just use those data, and then we assume that the next movement would be the same. We assume that it doesn't change at all. So yeah, that's what extrapolation is. But as you know, it's not very accurate. That's why we try to not use it at all. We want to do interpolation as much as possible because it's much more accurate. Yeah. So yeah, that's the proxy synchronization. It just take the data from the server and store it inside an array, and then we delay the display a little bit in order to have enough data to do interpolation. And when there is not enough data, we just do extrapolation. Okay, let me just show the interpolation. Yeah, last time I disabled my code and then just set the transform position directly to the position that the server sent, and now I do the interpolation, and let's see the difference. Now let's run the server, and then we have the combat, the client combat, and then here is the client. Okay, server is running, so that's good. Okay, and we connect with the other client. Here you go. Now new client arrived, and as you can see, it's a lot smoother. And you can see sometimes it jump. That means it just means the proxy was doing extrapolation. It jumped ahead of the new position when I actually stopped. I wasn't moving, but it jumped forward and then it jumped backward. That is extrapolation in action. But yeah, it makes the movement a lot smoother than we simply moving directly. And with a lot of client, with a lot of player around, having a smooth movement like that, it does give better experience to the user. Okay, that's it for the synchronization with the proxy, and it should be the end of the synchronization series in this series of video as well. Okay, thank you very much for watching, and I will see you in the next episode. I don't know what the next episode is, but yeah, we will see. Thank you very much for watching, and see you later.